Good morning, friends. Myself, Dr. M.H. Chennaiya, and in today's video, we are going to learn about some important examination tips to solve problems on pyramids. Friends, basically, we should know how to place the object. In all the projection of solids, generally there will be three steps or three stages. Initial positioning of the object is the first step. Second step, you are going to tilt the object on corner or on a base edge. And finally, we are going to have the second tilt. And all these will carry equal marks. If there are 20 marks allocated generally for this, there will be 7 marks approximately for every step. And it's just like mathematics, and for every step you do correctly, you get the marks allocated. Friends, here in today's video, I have taken up pyramids as the subject. That is, video on this subject is the pyramids. Friends, we have got a problem on a square pyramid. Friends, a square pyramid is basically a pyramid having a square base, and it will have on its lateral surface four triangles, and all these triangles are isosceles with base equal to the side of the base. So friends, if you are able to position the object correctly in the first position, I am assuring you, you will be able to complete the second part also very easily. So friends, let us consider this square pyramid resting on triangular face and base edge. So, how to get the projections of such a pyramid? Friends, here I have taken up a square pyramid having edge of base 30 millimeter, and the height of this is given to be 70. I have taken like that. And friends, now let us see how to place the object. If it has to rest on a triangular face, friends, similar to our prisms, one of the shorter edge of the base should come to your right side, so that that shorter edge along with the vertex will have a triangular face like this, and that can be made to rest on HP. Okay, now friends, whenever you have in the examination paper or in the question that the pyramid has to rest on one of its triangular faces, then the first step is, friend, you have to place the object on HP such that one of the edges of that is normal to VP. Obtain its top view and front view. Friends, top view is going to be a square with all these slant edges joined to the vertex, and I will just name this as A, B, C and D. Similarly, I am going to project all these to the front view and show this as A dash, B dash, C dash, D dash. O dash is the vertex, O1 is the center of the base, and very obviously the axis of the solid is perpendicular to HP. Friend, this is very important. Suppose instead of placing the object like this, if you had kept like this with one of the corner coming to the right, then the object, that is the pyramid, will never stand on the triangular face, it will be resting on a slant edge. That we are going to take it up later. Friends, I have got the front view, I have got the top view to the given dimension, and after that we have to see in the question, is it the triangular face on which the solid is resting, or is it the slant edge of the pyramid? Now friends, in the question, if you find that the pyramid is resting on one of the base edges, that one base edge should come to your right in the front view, the top view, that edge should be perpendicular to VP and it should come to your right side, because we are going to treat the object to the right side usually. Now next friends, if you find that it is resting on a slant edge, then corner should come. So here friends, if you find the term triangular face like our rectangular face in prisms, base edge are one of the shorter edge in case of prisms. So when you find these terms, base edge or triangular face in case of any pyramids, then friends, place this on HP such that one of the base edges is normal to VP and it comes to your right side. Similarly, friend, if you have a pentagonal pyramid, friends, say this is one of the triangular faces. When you write the top view, the base edges of that triangular face should come to your right side and it should be perpendicular to VP, so that when you make it and you rotate it through this angle, it will rest on the triangular face on HP. Likewise, friends, if it is a hexagonal pyramid, friends, one of the edges, say this edge should come to your right side, so that when you rotate the object about that edge on HP, it will rest on the triangular face on HP. Friend, this is a front view on top view you have got. So you get 1/3 of the total marks allotted for this question. Now, after getting the front view on top view, friends, you have to analyze the front view. What the analysis here? Friends, we should see what does these lines stand for. For example, say this last line here and this last line. So for that, you will have to find out how many number of points are there on that particular line. Friends, if you see this last line, it has got O dash, C dash, D dash. So there are 3 points on the extreme right line, this line. So since there are 3 points, this represents a triangular face which is inclined at this angle to HP. But in the question it says resting on triangular face. So what is to be done? This triangular face, that is, I will say triangular face, is to rest on HP. That is to say, if you call this front view as figure number 1, it has to be redrawn such that this O dash, C dash, D dash rests on the XY line, that's the HP. Friends, what I do, I construct that figure first. I will tell you how to construct also. Friends, say this is the position of this square pyramid in the front view when it is resting on one of the triangular faces OCD. So this is C dash D dash. Other part is A dash B dash. This is O1 dash and this is O dash. Friends, it's very easy. You can take this length and draw a line here, O dash, C dash, D dash. Then you know this is 30 with this C dash, D dash as center and radius equal to 30, you can draw an arc. Similarly with center O and length equal to this much, draw another arc. They intersect that point and we get the front view of the solid. Now friends, let us see what do we see in the top view. Friends, there's a very important concept involved here. Whenever any of these pyramids, any pyramid, rests on HP on one of the triangular faces or on one of these slant edges on HP. Friends, you can observe here, the complete base of the solid is visible in the top view. So this has to be remembered by you. So now I am considering the square pyramid. So if it is resting on the triangular face on HP like this, friends, you will be able to see the complete base. If it is a square pyramid, you see a distorted square, that is a rectangle in the top view. Similarly, if it is a pentagonal pyramid, you see a distorted pentagon in the top view. So, but the whole base is completely visible in the top view. So that concept is very important. So friends, I just explained to you that you will be able to see the complete top view. Let me start with this. So friends, the complete base means A, B, C, D. To obtain these 4 points, Let me draw vertical lines through all these. Vertical line from A and B, horizontal line from here. This is point A. Then from point B, this is going to be the point B. So you got A and B here. And then friends, this is CD. Yes, A and B you got here. Then C and D. So C, this is B, this point is C, and this point is D. Friends, I told you just now, complete base is visible and it will be automatically a rectangle. So friends, let me join all these. A to D, A to B, B to C, and D to C by straight line. This represents the base. Let us also mark what is the center of that. That is O1. So friend, this is how the base looks. If it is a pentagon, you will get a distorted pentagon here. If it is a hexagon, you are going to see all the 6 edges, base edges of the pyramid. Friends, we have got this O, right, a vertical line from O, a horizontal line from here. The point of intersection will give you O. So you are looking from this direction. So the complete base is visible. I have marked. And when you look from the top, friends, you can also see this line, this particular surface to say, that is OA and OB are visible. What is OA here? This is O and A. It is visible. I will show by full line. OB also by full line. This is how the edges OA and OB are connected. Then friends, you know that you have to connect the vertex to all the corners of the base. That is A, B, C and D are to be connected to O. I have connected O to A because this is visible. It's just like a sloping roof. When you see from the top, both the sides of the sloping roof are visible. So now friends, I want to join O to D. But while joining O to D, what happens friends? It is going to intersect this AB. So friends, remember, in solids, whenever two lines intersect, if one of them is known to be a full line or a visible line, the other should be compulsorily a invisible line, a dotted line. So I'll show you here. When I join this O to D, it intersects AB, and hence I have to show this by a dotted line, invisible line. Likewise, friends, when you join O to C also, it is intersecting AB, and hence, friends, I have to show this by a dotted line. This will mark it as B here. So, friends, we have got A, B, C, D completely visible, and two slant edges, namely OD and OC, are not visible, and I have shown them by full line. So here you can observe, friends, this OCD is on HP. So I'll write down here OCD or O dash C dash P dash, or the triangular surface is on HP. Hence it is seen as a line there. OCD is a triangular face and that is on HP. So this is how we should get the first and second position of the solid, whether it's a prism or a pyramid. So till here you get 2/3 of the total allocated marks out of 20, say. That is 20, then 2/3 means around 14 marks you get for the solid. Next, friends, let us take up the second case in the same figure. I will show you what happens if it is resting on one of the base edges. I told you, friends, whenever it has to rest on one of the base edges, the base edge has to be to your right side. And friends, this is the triangular face. It says it has to rest on base edge. So friends, it was like this, friends, or I can say it was like this, and now I am going to rotate to the right side. I will show you here like this, so that now the object is resting on one of the shorter edges of the base, and the axis gets inclined. So the first step is common. Instead of this now, since it has to rest on a base edge, friend, I will complete that figure and show you the construction. A line from here, say, I will tell you how to construct this also. Friends, same thing is written here. This will have a dimension of 30 and these two same as this. So this is the first position for the second part and this is the second position. Friends, here if I just marking this is A dash, B dash. This is C dash, B dash. This is O dash, so the vertex, and this is O1 dash. Now friends, if you observe this figure, the pyramid is resting on the edge CD such that the axis is at some angle to HP, and that angle will always be specified in the problem. Suppose say this is at an angle of 40 degrees to HP, or the base of the solid is making 50 degrees with HP. It means one and the same. And sometimes to confuse you, they will give you both. The axis is at an angle of 40 degrees to HP and the base, this ABCD, is at an angle of 50 degrees to HP. It means one and the same. Or in some of the problems, they will give you that the object while resting on one of the shorter edges, the base edge, the base or the highest edge of the base is at a distance of 30 millimeter from the base. So anyway, this inclination can be given. They can give you this height, or can give you the inclination of the axis, that is in most of the cases, or they can also give you the inclination of the base of the solid with the HP. So these are the three cases how they give you. Now friends, I'll place the object like this, friends. I'll show like this. The object is kept like this on HP. Friends, let us see how does it seen or how it is seen in the top view. For that, what is to be done, friends? I will take all these lines from there. So I will start from point A. The vertical line from A. This figure I am considering. So this I am not taking. This is for the first case. For the second case, so A and D are on the A. So simply I will take here. This is point A. And similarly on B, friends, you get a point here. This is going to be point B, A, B. I'm just locating the points on the base. This is C and D, friends. So let's extend that line. You will get this A, B. This point is going to be C, and this is going to be point D. And the center of this will give you the center of the base, which I marked it as O1. Friends, the vertex O dash is here. Write a vertical line from O dash, a horizontal line from here, and the point of intersection will give you the point O. The vertex is the center of the base. Now friends, first we should obtain all the points. And friends, I have to join this vertex O to all these corners. Before that, let me see how. If you look from the top, friends, you can see OA, you can see OB. So friends, I will just join O to A by a full line, O to B by a full line, because OA and OB are visible to the observer. Friends, next we have what is point D. I can join O to D by a full line because it is not touching any of these other slant edges. O to C also you can join by full line because all these form the borders of the figure. The borders of the figure are always visible and you will never show them by dotted line. So always these are joined like this, friends. And friends, if you observe here, the object is resting on CD. CD is one of the shorter edge, but that CD is not visible. I will show you practically. It is resting like this, friends. It is resting like this, friends. This is CD. When you look from the top, friend, the CD edge is not visible. Hence, that has to be shown by a dotted line or an invisible line. So I'll just mark like this, friends. Now we can observe, friends, the axis of the solid has become parallel to VP, and here the axis is inclined to the HP, and the object is resting on the shorter edge, one of the shorter edge, that is CD. The CD is on HP, and you are able to see the object. So this will give you, friend, the top view of the solid, and here this will give you the front view of the solid. So I'll show this by the visible line, dark lines, and this is how the front view of the solid is seen. This is the top view, this is the front view, and see, if you are writing for this question, resting on one of the base edges on HP such that the axis is at an angle of 40 degrees to HP, then friends, for this you get 1/3 the mark, for this you get 1/3 the mark. In the next step, they may say the edge on which it is resting is now perpendicular to VP, but that has to be at an angle to VP. So we have to redraw this figure and obtain the next position. So like this, friends, we will be able to complete the complete projections of the solid. So that is possible only if you remember that whenever the pyramids are resting on one of the shorter edges on HP, or the triangular surface on HP, for both of these and for all pyramids, you have to keep the object such that one of the shorter edge is perpendicular to VP initially. And friends, you can observe here, since the object is resting on CD, CD is one of the shorter edge here, and the object was resting on triangular face in the first case, and in the second case, first and third figure resting on base edge on HP, one of the base edge which is now perpendicular. Friends, for these two positions, you will get 2/3 of the total marks allocated. Friends, I hope the presentation was interesting, and if you have followed this clearly, you will not have any difficulty in solving any problem on the pyramids. In some of the videos to come, I am going to show you what happens to the projections when this is resting on the slant edge on HP. Friends, please go through the complete video without skipping anything. And if you like this video, don't forget to share with all your friends without fail. I wish you all best of luck. Have a wonderful day.